Okay, here we are. All right. So topic today is matrix multiplication possible? Okay. So we've covered matrix addition, matrix subtraction. Yeah, but then now I want to talk about matrix multiplication. Okay. So let's say we're given a matrix. Let's say I have these two matrices, 3 1, and this other matrix here, 4 2 1 1. Okay. So then we are given a question which says AB. Okay, so multiply matrix A with matrix B. So with matrices is not like with integers or real numbers, whereby when you say 2 by 3, you just say 2 by 3 is 6 done. But with matrix addition, matrix multiplication, you have to check first whether the multiplication is possible or not. So that's what we want to dwell on in this video. So we're not really multiplying matrices, but we are just checking whether the multiplication process is possible prior to even multiplying. Okay. So one thing to talk about, which is something I've been talking about in my previous videos, is the order of a matrix. So that's why I want us to have a clear understanding, because we also need the concept of orders here. Okay, so we said, okay, maybe let me just draw this line here. We said an order of a matrix is just the size of the matrix, how big or how small the matrix is. It's being computed by calculating the number of rows first, then the number of columns. Okay. If we have a matrix like 7 1 1, then 2 1 1. Okay, this is a matrix, and to find the order of this matrix, you calculate the number of rows first, then the number of columns second. You don't make a mistake of first counting the number of columns, then the number of rows. No, you calculate the number of rows first, 1 row, 2 rows. So we say this is a 2 by, then now we have to calculate the number of columns, 1 2 3. So we say this is a 2 by 3 matrix. Okay, so the 2 represents the number of rows, the 3 represents the number of columns. I think we are clear on that one. Okay, so with that being said, we come here. So if we're given matrix A and matrix B to be multiplied, it means we will say AB is equal to matrix A is 3 1 and matrix B is 4 2 1 1. Okay, so what you have to do here first, you have to find the order of the two matrices. So matrix A, its order is 2 by 1. You can see that we have 2 rows and 1 column. Yeah. Then matrix B, it's a 2 by 2, 2 rows, 2 columns. So we are saying these two. Okay, maybe let me just erase this. I want to open some space here. Okay, we're saying this is a 2 by 1. We say this 2 represents the number of rows, this one the number of columns, this 2 the number of rows, this 2 the number of columns. Okay, so the concept says, in order, or shall I say the rule says, in order for matrix multiplication to be possible, the number of columns for the first matrix, this one, the first matrix is matrix A. The number of columns for matrix A is 1. should be equal to the number of rows in matrix B, in the second matrix. So the number of rows in matrix B is 2. They should be equal. So in this case, matrix A has 1 column, whereas matrix B has 2 rows. So matrix multiplication is impossible. It's impossible. Okay. So in other words, we are saying these two numbers should be equal. And these two numbers, they represent, the 1 represent the number of columns in the first matrix, and the 2 represents the number of rows in the second matrix. So that the rule. It says for matrix multiplication to be possible, you can write this down. For matrix multiplication to be possible, the number of columns in the first matrix should be equal to the number of rows in the second matrix. Okay, so that's it. With that being said, I'll make another example so that you can have a feel for this. Okay, let's say we have a matrix, this one here, 0, 1, 3, 2, being, okay, no, I want to leave some space. Okay, 2, 1, 0, 7, 1, 1, multiply by, okay, this one, yeah. Okay, so again, we have to start by finding the order of the two matrices. So the first matrix is this one. The order of the first matrix, say it's 2 by 3. We have 3 rows, 1, 2, 3 rows, then we have only 2 columns. No, it's not a 2 by 3. I'm lying. We have 3 rows, so it's a 3 by 2. It's a 3 by 2. And then the second matrix, it's 3 by 1. Again, we have 3 rows and 1 column. Yeah, true. Okay, so is matrix multiplication possible here? So the answer is no. Why? Because these two numbers are not the same. So the number of rows, the number of columns in the first matrix, which is 2, is not equal to the number of rows in the second matrix, which is 3. So we are saying this matrix multiplication would be impossible. So that's how we tell. Okay, but then let me try to make an example of a matrix whereby it should be possible for the multiplication, so that you can see and appreciate what is going on here. Okay, the first matrix is a 2 by 2 matrix, as you can see. 2 rows, 2 columns. This one is a 2 by 2. And then the second matrix, we have 2 rows, 2 by, and 3 columns. 3 columns. Okay. So is matrix multiplication possible in this one? Okay. So the fact that these two numbers are equal, so we say matrix multiplication is possible. That's how we tell if matrix multiplication between 2 matrices is possible or not. And another thing to note here is that to recall, this 2, this one, the first one here, represents the number of columns in the first matrix. Then this 2 represents the number of rows. In the second matrix. That's why we said for matrix multiplication to be possible, the number of columns in the first matrix should be equal to the number of rows in the second matrix. That's how you tell if a matrix multiplication will be possible. Yeah, that's it. So I think now you can easily tell if a matrix multiplication is possible or not without even trying to compute your multiplication. Maybe just one last example. 2 1 and 1. Yeah, or let me just say 7. Okay, is it possible or not? It is possible. Why am I saying that? This one is a 2 by 1. The first one, 2 rows, 1 column. The second one is a 1 by 1. So these two numbers are the same. Hence, matrix multiplication is possible.